In this video we're going to see how we can use a tree diagram as a way of representing the probabilities of different combinations of events so that we can work out the probability of more than one thing happening. Before we do that, there is a couple of rules that you need to know from previous topics. First one is the OR rule. So this is telling us how we can work out the probability of one thing or another thing happening. So this is saying the probability of event A or event B happening is going to be the probability of event A happening by itself plus the probability of event B happening by itself. This rule should make sense because if I'm talking about one thing or another thing happening, you would expect the probabilities to increase, a higher chance of it happening because it can be either of them. Hence why we are adding the two probabilities together, because we'll get a bigger probability. So this might be, for example, the probability of getting a 5 or a 6 on a dice. And that's going to be the same thing as the probability of getting a 5 plus the probability of getting a 6. The second rule you need to know is the AND rule. So this is the probability of one event, event A and event B happening. So both things happening. So both of these need to be true. And because of that, we multiply the probabilities together. So the probability of A and B occurring will be the probability of A multiplied by the probability of B, which should hopefully make sense because when I know that probabilities are always fractions, they're always numbers that are less than 1. And if I multiply two numbers that are less than 1, I will get a smaller number as my answer. So I will get a smaller probability as my answer, which, like I say, should hopefully make sense because if I want the probability of A and B happening, they both have to happen and I would expect to get a smaller probability as a result. Anyway, just remember, if one thing or another thing, add, both of them multiply. So let's have a look at an example tree diagram question, which is this. So there are 20 biscuits in a tin. 12 of them are plain biscuits, 5 of them are chocolate biscuits, and 3 of them are ginger biscuits. 2 of the biscuits are taken from the tin, and I want to find what's the probability that those two biscuits are going to be different. So first thing I'm going to write down here is I'm going to focus on the probabilities just for that first biscuit. So let's focus on that. So what's the probability that the first biscuit taken out of that tin is plain? Well, we saw that there were 12 plain biscuits and 20 biscuits in total. So it would be 12 out of 20. I've got 12 chances out of 20 in total of getting a plain biscuit. So that's the probability that the first biscuit is plain. The probability that the first biscuit is chocolate will be 5 out of 20. And the probability that the first biscuit is ginger would be 3 out of 20. So there's 3 gingers. We should always check to make sure that we've not made any silly mistakes here, because if we add these 3 things together, these 3 probabilities together, it should always equal 1. So 12 plus 5 plus 3 is 20. So 20 out of 20 is 1, which is correct. It should add up to 1 because we know that all probabilities add up to 1 because that's the maximum probability can be. That's saying that it's definitely going to happen, a certain event, and one of these 3 things is definitely going to happen for the first biscuit. So that's the easy bit. Now we're going to move to the probabilities for biscuit 2. So we are first going to focus on the probabilities of that second biscuit being plain. So what's the probability of the second biscuit being plain? Now I'm making an assumption here that the person taking that biscuit, taking the first biscuit, did not put it back into the tin. I'm assuming they ate it because it would be a bit weird if they put it back into the tin. So you can see here that there were 12 biscuits to begin with, 12 plain biscuits to begin with. And if they took one plain biscuit out, then there's only going to be 11 plain biscuits left now. And we can see that there were 20 biscuits to begin with. And if we took one plain biscuit out, then there's only going to be 19 biscuits left. So there's 11 plain biscuits left now out of 19 biscuits in total, because we took one plain one out. Chocolate. Well, there were 5 chocolate to begin with, and we didn't touch any chocolate biscuits. We only took one plain one out. So there's still 5 chocolate biscuits left out of the 19 in total. Ginger. Well, again, there were 3 ginger biscuits to begin with. We didn't touch any of them. We only took one plain one out. So that means that there's 3 ginger left out of 19. So these are the probabilities of getting a plain, a chocolate or a ginger if we took a plain out the first time. Now we'll move to working out the probability of each of those events if instead we had taken a chocolate out the first time. So if we took a chocolate out the first time, there would still be 12 plain biscuits left out of 19. Because we didn't touch how many plain there were. There were 12 plain at the beginning. We only took one chocolate out. So that means there's still 12 plain biscuits left. There's only 19 biscuits left in total because there were 20, but we took a chocolate one out, hence why it's 19. The probability of the second biscuit being chocolate, well, like before, there was 5 at the beginning, but I took one of them out, so there's only 4 left now. So there's 4 chocolate left out of 19 in total. So that's the probability of taking a chocolate biscuit out as the second biscuit if I took a chocolate the first time. Ginger, there was 3 to begin with. I didn't touch them, I only took a chocolate out, so there's still 3 left and there's 19 left in total. And then finally, the last situation for the second biscuit is if I took a ginger out the first time. I didn't touch the plain, so that's 12 out of 19. I didn't touch the chocolate, so that's 5 out of 19. I did take a ginger out. There were 3 to begin with, so there's only 2 ginger biscuits left now out of 19. So these here represent the probability of the second biscuit being plain if I took a plain the first time, the probability of me taking a chocolate the second time if I took a plain the first time, the probability of a ginger the second time if I took a plain the first time, the probability that I took a plain the second time if I took a chocolate the first time, then chocolate the second time if I took chocolate the first, ginger the second if I took chocolate the first, plain the second if I took ginger the first, chocolate the second if I took ginger the first, ginger the second if I took ginger the first. So that is my tree diagram. Now it's actually about using this so I can work out the probability of combinations actually happening, because these are just talking about individual probabilities. So the question asked to find what's the probability that the 2 biscuits were different. Now I'm going to show you this final part of my tree diagram now, and I'll explain where all of these numbers come from. So this 132 out of 380, that is the probability of me taking a plain the first time and a plain the second time, because I have done 12 out of 20 multiplied by 11 out of 19. Remember that I want to multiply probabilities together if I want to find out the probability of this and this happening. So if I wanted to work out the probability of a plain and a plain, I times those 2 together to get this. The probability of getting a plain the first time and a chocolate the second time, so plain times chocolate, plain times ginger, chocolate times plain, chocolate and chocolate, chocolate and ginger ginger and plain, ginger and chocolate, ginger and ginger. So these numbers on the end here, these fractions on the end, they represent the probabilities of each of these different combinations. Now, to answer the question then, I was told to work out the probability that the biscuits were different. So that could be working out the probability of it being a plain and chocolate, they're different. Plain and ginger, they're different. Chocolate and plain, chocolate and ginger, ginger and plain, ginger and chocolate. Now I've just worked out all of these values over here. So plain and chocolate is this number here. Plain and ginger is this one. Chocolate and plain is this one. Ginger and chocolate is this one. Ginger and plain is this one. Ginger and chocolate is this one. Not that one on top, that was the plain and plain. So these here are all of the 6 different probabilities. And because it could be any of them, it could be this one or this one or this one. That's why I'm adding all of them together. So I could add all of those numbers I just circled together. That's one way of doing it, and that will give you the correct answer. That will, if I add all of them together, I'll get 222 out of 380. And that is the correct answer. But there is a slightly more efficient way I could have done that. Instead of working all of these out, instead of working out all the different ones, what I could have done is I could have done 1, take away the probabilities that they were all the same. That will be the same thing as working out the probability that they're both different. The probability that they're the same would be plain and plain, and chocolate, and ginger. So adding them together would tell me the probabilities that they're the same. So if I add plain and plain together, and chocolate together, and ginger together, if I add them together, I get 158 out of 380. And then if I take those away, do 1 take away this, you can see I get the same answer. So you can do it either method. That's slightly a longer way than this, but that is how we can use tree diagrams to work out the probability of more than one thing happening. So key things here: if I want one thing or another thing happening, I need to add the probabilities together. If I want one thing and another thing to happen, I need to multiply them together. And the other key thing to look out for here, whether the probabilities for taking biscuit 1 and biscuit 2 change or not. If in the question I'd been told that the person had put the biscuit back in the tin, these numbers here would have been exactly the same as these numbers here, because the probabilities wouldn't have changed. Same idea, these would have been the same as these, and so on. So you need to read these questions carefully to figure out, should these numbers here be the same as these? Are these 2 events the same? Or are they different, as they are in this case?